Okay, so today we're going to learn, really our big goal is how do we identify compounds as either covalent or ionic? Okay, so we'll talk about what makes up each, and then we'll learn if we look at the formula, how do we know? First we're going to start with covalent compounds. Covalent compounds are also called molecular compounds. Okay. Those words can be used interchangeably. Okay, so molecular or covalent, either's fine. I tend to find myself saying covalent more, okay, but molecular is completely fine. Okay. These compounds are typically going to be made up of a nonmetal bonded to a nonmetal. Okay. So if I were you, I'd highlight, star, underline the nonmetal part. So examples of molecular compounds that you're probably familiar with are water and carbon dioxide. And so let me show you what I mean by nonmetal plus nonmetal. So the first element in water is hydrogen. And is hydrogen a metal or a nonmetal? Okay, nonmetal. The second element is oxygen. Is it metal or nonmetal? Okay, so do you see how both of the elements are nonmetals? So that's what I mean by nonmetal, nonmetal. The properties of molecular compounds tend to be a lower melting point and a lower boiling point. So that's why in our lab, these ones melted first. So they melt at lower temperatures, which is why they melt first. Were any of you able to see it melt to a liquid and then it boiled even? Maybe. Okay, so they also have low boiling points. These ones are typically gases or liquids at room temperature. Okay, so think water is what at room temperature? Liquid. What's CO2 at room temp? Gas. Okay. So most of the time they're a liquid or a gas. Are there, of course, exceptions like the ones I gave you in the lab today? Yeah. All right. So then if molecular or covalent compounds are typically nonmetal, let's refresh where our metals or nonmetals are. So do you remember last class we colored the periodic table, the metals and the nonmetals? Okay. What side of the periodic table are the nonmetals? Right. Okay, right side. So everyone take a look at your paper periodic table. Okay. This is the one we use on tests, so get familiar with this one. Okay. Do you see how you have this bolded staircase? Okay. That bolded staircase, it's splitting the metalloids in half, and it's really breaking up the periodic table into metals and nonmetals. Okay. So we're going to call everything to the left as a metal, everything to the right as a nonmetal, with the one exception of hydrogen. Okay, hydrogen is a nonmetal. Okay, so when we're looking to see if something's molecular, all the elements should be in this section of the periodic table. Yes? Okay. Next we have ionic compounds. In the word ionic, do you see ion? Okay, so ionic compounds, they're made up of ions. And it's always a cation plus an anion. Okay? Always, always, always. What kind of charge does a cation have? Okay, positive. What kind of charge does an anion have? Okay, what do positive and negative charges do? What do opposite charges do?
Cancel each other out.
They do cancel. But what do opposites also do? Attract. Right? So it's the attraction of that cation and anion that makes this compound form. Okay. That's 100% of the time. Most of the time, that's going to look like a metal plus a nonmetal. Okay. So again, if I were you in my notes, I would highlight, star, underline this metal plus nonmetal. And then these compounds, even though they're made up of ions with charges, overall they're going to be electrically neutral. So whatever the plus charge is going to get balanced and canceled out by the negative charge. Okay. So an example is table salt. Have you ever gotten electrically shocked by touching table salt? No, right? Because it's neutral. Okay, so even though they're made up of ions, the compound itself is neutral. And then these ones are typically going to be solid at room temp. Okay, so then let's look, how would we identify ionic compounds? For the most part, you're going to go with metal plus a nonmetal. Okay. So again, what side of the periodic table are the metals found? Okay, left of the staircase, nonmetals, right. So we would be expecting an element, one of each. Okay, so 98% of ionic compounds will be metal plus nonmetal. Okay, there are a couple exceptions, and we will get to those a little bit later, but it'll always be a cation plus an anion. All right, so most of the time when we look at our formulas, they're on paper. Okay, so we just need to understand how to read a chemical formula, and then in the next slide, we'll learn how do we know if it's ionic or covalent. Okay. So if I were you, on this slide, go ahead and just copy down this formula here. Okay. So when we do chem, we use chemical formulas. They show us what elements make up the compound, but then they also show us the number or the quantity of each element present. Okay. So we need to know these numbers and how they distribute. Does anyone remember, like from math class, what do we call this large number that comes in front of something? Good. The coefficient. Okay. So if I were you, I would like write that formula and then it would like label how I'm labeling. So the big number in front is called the coefficient. This number distributes to the whole thing. Okay. So that means that there's 2 of these calcium hydroxide compounds. So it means we have 2 of these. Does that make sense what that 2's doing? Okay. All right, what's the other number you see? The little 3, do you know what we call the little numbers? Good. So the little number is the subscript. Okay. This subscript only applies to the element that comes right before it. Okay. So it's only giving the quantity of the element it's like touching. Okay. So this is saying that there's 3 calciums in this whole compound. Okay. So if we were to draw like this calcium hydroxide, there'd be 3 calciums plus this hydroxide. Okay. So just kind of to recap, the coefficient applies to the whole thing. The subscript only applies to the element that comes right before it. Okay. And does that line up pretty much with what you've learned in math class about coefficients and subscripts? Good. It's the little number. Okay, the last thing we can grab from the chemical formula is just the type of elements that are present. So how can we tell one element from another? Good, capital letters. So every time we see a capital letter, we know it's a different element. Okay, so the last thing we're going to do, and this is the big goal of the day. If we're looking at a formula, we have to be able to label it as ionic or covalent/molecular. The reason is, when we get into our naming rules, ionic compounds have one set of naming rules, covalent have a different set of naming rules. Is it important you know how to identify it so you know which rules to use? Okay, this is like step 1. So your goal today before you leave is you need to be able to look at compounds and identify them as ionic or covalent. Okay. All right, so our first one is KCl. What's the first element present? What's the letter at least? Okay, K, which is potassium. What's the second element? Chlorine. Okay, how can you tell like the division of the first versus the second element? Perfect, the capital letters. So you're gonna look at capital letters to know that's how you separate them. Okay, and then we're gonna look where they fall on the periodic table. Okay, so find potassium. Is it a metal or a non-metal? Okay, it's a metal. And then find chlorine. Is it a metal or a non-metal? Okay, so if it's metal and a non-metal, what is it? Good. Okay, our next one, what 2 elements are in this next one? Okay, carbon and oxygen. What side of the periodic table is carbon on? Right, so metal or non-metal? And what about oxygen? Okay, so 2 non-metals, what will that make? Good. Covalent or molecular, either name is fine. Okay. Next we have strontium selenide, or SRSE. Okay. What are the 2 elements present? Okay, so SR is the metal, SE is the non-metal, so how would you label that? Good. Okay. Ionic. Fourth one is barium oxide, so Ba and O. What's Ba? Barium. It's number 56. Okay, metal. Good. Metal and non-metal is? Ionic. Okay, can you try the last 4 without me? Okay, try the last 4. All right, how did you label calcium chloride?
Ionic.
Okay, ionic. Why was this one ionic? Good. Okay, what did you label SO3? Okay. Why? Okay, what about CCl4? Good. Why covalent? And what about NGF2? Okay, why? Okay. While we were doing those, did any of you notice maybe like a shortcut? Okay, most of them said they have 2 letters of metal. Okay. Any others? Did you notice? What is the second element every single time? Okay, every single time it's a nonmetal. So that means which element is going to determine if it's ionic or covalent? Okay, the first one. So if you want to look at an element and figure out if it's ionic or covalent, do you really need to look at both or just one? Okay, just one, and which one? Okay, the first one. If it's a metal, what will it be? Okay, ionic. If it's a non-metal, what will it be?